Lesson 5.7, Scatter Plots and Trend Lines. The objective of this lesson is to write an equation of a trend line and of a line of best fit, and to use a trend line and a line of best fit to make predictions. There are a lot of vocabulary in here, so if you want to use the notes section or the back where there's sample problems to put these vocabulary words, you can. Scatter plot, a graph that relates two different sets of data by displaying them as ordered pairs. Positive correlation, the relationship between two sets of data in which both sets of data increase together. Negative correlation, the relationship between two sets of data in which one set of data decreases as the other set of data increases. No correlation, there does not appear to be a relationship between two sets of data. Trend line, a line on a scatter plot drawn near the points, it shows a correlation. Interpolation, the process of estimating a value between two known quantities. Extrapolation, the process of predicting a value outside the range of known values. Line of best fit, the most accurate trend line on a scatter plot showing the relationship between two sets of data. Correlation coefficient, a number from -1 to +1 that tells you how closely the equation of the line of best fit models the data. And causation, when a change in one quantity causes a change in a second quantity. A correlation between quantities does not always imply causation. You can determine whether two sets of numerical data are related by graphing them as ordered pairs. If the two sets of data are related, you may be able to use a trend line to estimate or predict values. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. Most scatter plots are in the first quadrant of the coordinate plane because the data are usually positive numbers. You can use scatter plots to find trends in data. The scatter plots below show the three types of relationships that two sets of data may have. So in this first graph, when y tends to increase as x increases, the two sets of data have a positive correlation. So all of the scatter points are going up and they all seem to be increasing at the same time. In this graph, we have when y tends to decrease as x increases, the two sets of data have a negative correlation. All the points are going down. And in this third graph, when x and y are not related, the two sets of data have no correlation. None of the points are all going up or going down, so this would have no correlation. Making a scatter plot and describing its correlation. Problem 1. The table shows the altitude of an airplane and the temperature outside the plane. Make a scatter plot of the data. What type of relationship does the scatter plot show? So when you're making a scatter plot, we're going to use the altitude on the x-axis. So we would put 0 here, 500 here. I'm just going to write it like that. 1,000 here, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500, and 5,000. Okay, and then we'll put the zeros down here. You obviously guys are going to practice this with graph paper. Okay, and then the y-axis we would say is the temperature. Now it goes from 0.6 all the way up to 61, so you could just go up by 10. Obviously, like I said, yours is going to come out so much better than mine, but I just want to show you what it looks like. So obviously, this looks like mumbo jumbo, but when you guys graph with graph paper and everything, it's going to come out nicer. So you would plot these as 0, 59. So it would be somewhere up here. 559.2. 1,061.3. That would be up here more. 1,555.5. 2,041.6. 2,529.8. This would be 10, 20, 30, somewhere around here. 3,029.9. 3,518.1, so it would be somewhere over here. 4,026.2, 4,500, 12.4, and 5,000, 0.6. Be somewhere around here. So first you would plot all of the points, okay? And step 2, we would determine the type of relationship that the scatter plot shows. So the temperature outside the plane tends to decrease as the altitude of the plane increases, so the data have a negative correlation. And in this problem, if the scatter plot didn't really make sense to you and you didn't realize, oh yeah, it's negative correlation, just think of what the problem is talking about. It's talking about the temperature outside and the altitude of an airplane. So obviously as you go higher up in the airplane, the temperature is going to be colder. Trendline, interpolation, and extrapolation. When two sets of data have a positive correlation or negative correlation, you can use a trend line to show the correlation more clearly. A trend line is a line on a scatter plot drawn near the points that shows of correlation. So positive would be like this, and negative would be like this. You can use a trend line to estimate a value between two known data values or to predict a value outside the range of known data values. Interpolation is estimated a value between two known values, and extrapolation is predicting a value outside the range of known values. Problem 2. Make a scatter plot of the data below. What is the approximate weight of a 7-month-old panda? So step 1 would be to make a scatter plot and draw a trend line. Estimate the coordinates of 2 points on the line. So I'm not going to really do this for you because I don't have that much space. But again, your coordinates over here would be 1, 2.5. You would plot these points. 2, 7.6, and so on. So you would plot these points and you would draw a trend line. Step 2, you're going to write an equation of the trend line. So you would use two known points. So 4, 17.1, and 8, 37.9. And you could obviously use two of any one you want because they are on the trend line. So first you want to find the slope. y2 minus y1 over x2 minus x1, the slope is 5.2. And then you use one of the points, just like we did in the beginning of the chapter. So we're going to use 4, 17.1, and 5.2. And we get the equation y equals 5.2x minus 3.7. And then step 3, estimate the weight of a 7-month-old panda. Substitute 7 for x in this equation and solve for y. And you get y equals 32.7. Remember, the weight is measured in pounds. So the weight of a 7-month-old panda is approximately 32.7 pounds. And we'll do more of this stuff tomorrow. So line of best fit, correlation, coefficient, and causation. The trend line that shows the relationship between two sets of data most accurately is called the line of best fit. A graphing calculator computes the equation of the line of best fit using a method called linear regression. And again, we're going to practice more with this tomorrow. The graphing calculator also gives you the correlation coefficient R, a number from -1 to +1, that tells you how closely the equation models the data. The nearer R is to +1 or -1, the more closely the data cluster around the line of best fit. If R is near +1, the data lie close to a line of best fit with a positive slope, and if R is near -1, the data lie close to a line of best fit with negative slope. Causation is when a change in one quantity causes a change in a second quantity. A correlation between quantities does not always imply causation. So let's look at two examples. So example 1, the number of loaves of bread baked and the amount of flour used. So we would have to compare these. There is a positive correlation and also a causal relationship. So as the number of loaves of bread baked increases, the amount of flour used increases. Example, the number of mailboxes and the number of firefighters in a city. There is likely to be a positive correlation because both the number of mailboxes and the number of firefighters tend to increase as the population of a city increases. However, installing more mailboxes will not cause the number of firefighters to increase, so there is no causal relationship. Causation is when a change in one quantity causes a change in a second quantity. So in the first example, the number of loaves of bread baked will increase, therefore the amount of flour used will also increase because you need the flour to bake the bread. However, in the second example, number of mailboxes and number of firefighters in a city have no relationship. So although there will be a positive correlation, there will be no causal relationship.